All right, so this is the Operator Lifecycle Manager Working Group. Today is Thursday, July 2nd, 2020. Let's take a look at the agenda just to see what we have for today. So the only proposed agenda for today right now is Mike is going to do a rundown and a demo, I guess, of the Operand Lifecycle Manager, ODLM. So, Mike, are you on the call? Are you ready to go? I see you there, but I'm wondering if you're talking, if you're muted.
Oh, I'm talking. I've been talking a while. Sorry about that. I am on the agenda. I'm on, obviously, and I'm ready to share. If you can talk me through how to share, do you have to give me permission?
I don't think so. So you should be able to, if you put your mouse over the actual middle of the screen, the drop down
Share
on the
screen.
top.
Here we go. Can I choose a number of application windows? And I'm just going to share the whole screen. This is the easiest way to do it. So I'll share the whole screen. Share. Can you see my screen?
Not yet.
Not yet. Now I'll try it. I'm sharing my screen. Now you can see it, right?
I see a screen now. Yep.
All right. So what I thought I'd do is kind of show a few slides as a background to the Operand Deployment Lifecycle Manager, which I kind of consider as an extension or, an opinionated way of deploying operators in their operands. And that's why we focused on operands. It was really a way of deploying operators in their operands in a prescriptive way for some of our common services that we use inside of OpenShift across our different cloud packs or cartridges and so on. So at a very high level, an example is you have, a cloud pack operator running in a cloud pack namespace and it's deployed a number of pods, and it needs to leverage some of the common services that we have running. Now, we don't install a common service in every namespace that asks for it. These are generally cluster level services that are shared across different cloud packs or cartridges or even certified containers that are running in the same cluster. In other words, how do we deploy these common services only when they're requested? How do we attach them to cloud packs that need them so they might interact with the service if that's required? And how do we remove services that are no longer required within the cluster if a cloud pack indicates that it's no longer needed? So we have an opinion and way of deploying, if you will, services that are nothing more than operator deployments of the services themselves, and they have operand pods in common services. And that's using something we call ODLM. And I think in the last time we did this, I posted a link to ODLM in GitHub. It is something that we're collaborating with in open source. And of course, we accept PRs and discussion on that. But I just wanted to show a little bit of how it works. In general, the technique is that when the Cloud Pak installs or one of its pods installs, someone creates a CR that says, hey, I want to use something out of the common services registry. The registry is a CR that's created for ODLM in the common services namespace, and they request that service. They do that through a CR that they create in their own namespace. So ODLM is watching cluster-wide. And once they've asked for that, if it's in the registry, if it's not installed already, we actually create a subscription to OLM for what they asked for. And I'll show some more of the technical details in a second. That causes us to deploy then the service in the common services namespace as requested by the Cloud Pak. And then as a last step, we provide credentials back that allow you to interact with the service. Okay. So if there's a URL or routes or TLS certificates or secrets or config maps that are needed to interact with the service, we pass that back. A more technical way of looking at it is this slide. Operand requests are CRs are created in the Cloud Pak namespace. They go against an operand registry. Think of that as a registry of common services that we make available to the Cloud Pak namespace. Each of those has a configuration, and what those are default CRs that are used by that particular operator for us to actually deploy that operator in the namespace. So the sequence is, I ask for application metering from this registry. This registry knows how to create a subscription to OLM for application metering, and then that subscription comes in and I have the metering operator then running in this namespace. Using this configuration, I create a CR to instantiate the operand for that operator. That actually deploys the operands. If there are any secrets or config maps that this operand wishes to deploy, to expose to consumers of that service, I create a CR for that called an operand bind info. That is then copied by ODLM over to the requesting namespace. And then you can use something like Red Hat service binding operator to bind these into the pods by mounting them. Okay, does that make sense? That kind of flow to everybody? Kind of involved, but basically there's a registry. I register some services in this registry. I can request one of those services. That request causes a subscription to occur. I pull in a CR with default attributes and create that CR after the subscription is active, which causes the operator that came into the common services namespace to deploy its operands. If they want to expose something, they create a CR called operand bind info that ODLM operates on and copies the secrets over to the requester's namespace to be bound into their pods. There's a little bit of binding going on, as well as sharing of instances, if you will, of operands across namespaces. Okay? Any questions on what I've shown you so far? Okay. So what I'd like to do is kind of show it to you in action. It takes a while for operators to deploy, obviously, so we'll run this like a cooking show. I'll show you what I did. I'll start our operation off, and I'll switch to another cluster so that our operation is already concluded. I wanted to show you a more detailed demo today in this cluster here, but I ran into this error here, right here, in dependencies between OLM that came up in like 4.7 or 4.8 of OpenShift. I happen to be running on a 4.10 cluster where we wanted to pull in other services automatically by default. I was going to show you a Cloud Pak for integration, automatically pulling in common services and binding to them, but that it pulled from the wrong channel because it wasn't respecting the default channel for a required CSV. So that didn't work. So I'm not going to show you those aspects today. When I get a cluster in an earlier version, or when this problem is corrected, I can show that to you in upcoming version if you want to see that in more detail. Instead, I'll kind of simulate that through showing you operator interactions and actually showing you a binding and getting my secrets back and stuff like that as I go through this, okay? So in the operator catalog, we currently have an IBM catalog, but I'm not running on 4 or 5, so it doesn't show up. It's here under a custom catalog. What our Cloud Paks will do is they will have as a required CSV our common services operator. And as you can see, I've already installed it. So they'll actually declare this as a prerequisite for them. What this operator does is it bootstraps this ODLM component and it creates a common services namespace like I showed you in this diagram over here in the cluster, and then it populates a registry that they can choose services from. These are services that we've already published to our Cloud Paks. They know the services are available, they know how to ask for them, and so on. So it'll bootstrap and install the operand deployment lifecycle manager. And as you can see, that's installed here. in the Common Services namespace. So if I jump into the Common Services namespace and look at installed operators, when I installed the IBM Common Service Operator, I deployed an Operand Deployment Lifecycle Manager. These are both cluster scoped, but I created a Common Services namespace. And in that Common Services namespace now, there is a registry for common services that, if we look at the YAML, lists a number of common services that can be installed. And so the metering operator, the licensing operator, our MongoDB operator, our cert manager operator, and so on are those services. And you can see there's a list of operators that can be requested from other namespaces to be installed. And when they're requested, there's other information in here as to what channel to create a subscription on, what the package name is, what the source name is, in this case, Open Cloud Operators, which is currently an operator source as opposed to a catalog source. We're going to move that to a catalog source, and where the namespace is in OpenShift Marketplace. So we added the IBM catalog, we added the Open Cloud Operators catalog, and so if this is selected, the IBM metering operator, by some request, ODLM will say, okay, here's the channel I need to subscribe to. But first it'll say, is this already installed? I haven't talked a lot about that. If it's already installed, then it won't install it. It'll simply pass back the credentials that are needed to install that. So in this cluster, I have, does that make sense to everybody? We just have operators and their names that can be requested to be installed from other namespaces, from this registry, and all the data I need to create a subscription. Okay? All right. It's Virtual Friday or whatever, so I don't expect a lot of questions, I guess. Yes.
Can you hear me okay? Yeah, so I was going to say, one of the powerful things about this is this gives products a way to bind in operator channels. So this is the feature I kind of brought up last time, is it'd be nice if we had a channel constraint. We're going to get version constraints, but this allows us to get that channel constraint in. So this registry is essentially a set of potentially compatible operators and those channels that we want to be able to pull from when we're wiring up our operands. So that's the powerful feature I think is powerful that we bolted on to be able to get that kind of consistency we're looking for.
Yeah, so we do specify the channels that they can pull from. And we could have a mix of different channels, but we don't, because we are really focused on compatibility, backward compatibility with the adopters. So the requesters over here can only request from this catalog, and that's what I was just showing you, is that catalog in detail. And that catalog only gives them certain choices. They can't request something that isn't there. So those choices are all married to particular channels for the operators and operands that they want to deploy. Okay? And I think that was your point, Chris, right? So you can see that each one of these has a channel, and each one of these is a different operator, has a source name and a namespace, and so on.
Yeah, so just as a reminder for folks, Cloud Paks are basically collections of software, collections of operators that are all wired together. And so this is a way that we can build a solution from a whole bunch of different operators, of which are products.
Okay. I won't get in a whole lot more gory detail than this. If with the installed operators, as I mentioned before, we have a registry that I showed you. We have a config. I'll show you a config real quickly. A config simply says if I install something from the registry, like the metering operator, here's the CRs I need to deploy. There's no parameters in the CRs. It means use the ALM example from the operator to instantiate the specific operands to create that, to cause that operator to actually deploy its operands. So depending on what you're doing, MongoDB, I could go in here and put replicas :3 or :1 if I wanted to change the replicas that would normally come in and be installed with MongoDB. I leave it at the default, which for us is 3. But I could customize this a little bit, and even specify specific operands for, specific CR attributes that would cause those operators to be installed in a certain way too, with certain characteristics. And so we're looking in the future at being able to modify these for certain profiles. If we're in a small cluster where developers using, container ready or code ready for containers, that's the word I want to remember. OpenShift on their laptop, they can install essentially small versions of these operators of our services and so on. So it gives us not only the channel constraints, but constraints on how we want these operators in their operands rather deployed. Okay. Well, what we haven't done is we haven't deployed an operand request. An operand request would be, again, a request usually from another namespace, but I'm going to install it in the same namespace. It works if I install it in here. It says I want one or more of the things running in this registry in my namespace. Okay. Let me just do that very quickly. If we looked in the registry, and I just showed you a bunch of entries in the registry, if I create an operand request, I could specify a list of things that I want from the registry in the current namespace, the registry called Common Services. So I want the cert manager, MongoDB, our IAM operator, our management ingress, our common UI, our platform API. These are all operators I want to install, and they will not only install the operators, but it will deploy their operands in this opinionated way I've been talking about into the cluster. And so the minute I create this, ODLM starts working on those. It starts creating subscriptions for each of those. And if we go and look at installed operators, we can see that we've started to install the different operators that I've asked for in IBM Common Services. And they're all they're all coming up. They're all deploying based on their CRs in their default mode or the way they were configured. And at the end of that, they will all be up and available. So cooking show. After that's occurred, in another cluster, Common Services, if I go and look at all the pods running, these are the pods for all the operands as well as the operators in Common Services. Okay. Now I just happen to do that from my own, from my own namespace, from the IBM Common Services namespace. If I were, say, a Cloud Pak and I wanted to use IAM for authentication and for defining my users and defining authorization policies to particular Cloud Pak resources, things like topics in Kafka queues or database administration for databases I might have deployed in Common Services, I could do that. And so I'll illustrate how that's done fairly quickly. I'm in the default namespace. There's nothing running here. The installed operators are only Common Services operator and the ODLM because they're cluster operators. But if I go to look for operand requests, I don't have any operand configs. I don't have a registry. There's nothing really deployed in this namespace, as you can see. Now I'm going to simulate what a particular Cloud Pak might do, saying, hey, I need to interact with IAM running in Common Services. And so if I jump back over to the Common Services namespace, I can see, in fact, IAM is running. These three pods, the authorization, IDP, PAP, and PDP, make up IAM. We can see that the installed operators include the IAM operator, and those are some of the pods that are running. Okay. But now I'm in default namespace, and I want to be able to interact with the IAM service that has been deployed, or if it's not deployed, it will be deployed in Common Services. I'm going to create an operand request, and pardon me jumping around here a little bit. I didn't want to have to type all this in while showing it to you. I'm going to create an operand request that looks like this. I'm going to say that I want to create an operand request for the IBM IAM operator. And not only do I want it up and running, but I want you to create secrets in my namespace called myauth secret for the public auth cert, myauth IDP for the public auth config, and so on. So I want you to create these secrets and or config maps in my namespace, and I want them to hold information that IAM exposes. Okay. Again, the registry is called Common Service. It's in the Common Services namespace. And so when I submit this in my own namespace, the default namespace, ODLM will read it and deploy and then copy secrets back over to my namespace. Before I do that, I'll just show that I'm not making this up. I want to show you that I don't have any config maps that start with my or secrets that start with my in my namespace, okay? So again, going back to installed operators and opening up an operand request and creating one, and this is normally be done programmatically, obviously. And in creating it, it will be submitted, it will run, and hopefully it will run fairly quickly. There is, I think, a bug that I saw earlier. Let's see if that bug still exists. No, this is running. So it's running. So I installed this simple request for the common services IAM. It's running. IAM is now available to me. It created these secrets down here, my auth IDP credentials, my auth secret, my auth OIDC credentials. It also created some config maps for me to now use in accessing. You can see a lot of data here in accessing what I need to do to to interact with IAM running in the IBM Common Services namespace. So just asking for that connected me to, if I go to IBM Common Services, this IAM operator and its operands right here that are running in that namespace. Okay, so what happened is, I'll go back to my PowerPoint, is IAM here, like is shown, deployed. It had some secrets and config maps. It actually has a bind info that tells me what to bind to for somebody requesting this from another namespace. If we go and look at that bind info over here, which I haven't shown you, in this namespace, I find ODLM and I look at its, and I look at bind info. Let's look at it up here. I'll see that there's an IAM bind info CR out there, and it says, whoever wants to bind to IAM, here's the things that they can ask for. They can ask for these. Here's their key, and whether it's a secret or a config map. Here's what it corresponds to in this namespace. When I went and asked for it, I gave it different names. And so it created secrets in my namespace, the default namespace for each of those. If we go and look at my operand request, so I put my in front of all of those. So it asked for all of those things. What that actually caused it to do was ODLM took the deployed IAM, took the bind info and said, oh, he needs to bind to these secrets, these config maps, created them in my namespace with the names I specified. So I can now take these in using the Red Hat service binding operator, bind them into my pods if I want to. But you can see it actually did create those secrets down here. It did create the config maps and so on that I asked for. So now they're available to me as a workload. If I had a workload, I could use the service binding operator and inject those into my pods, and then they would be able to interact with IAM. Like I said, I wanted to show it all to you, soup to nuts, with a Cloud Pak actually using that. Maybe that is something we could do next time. I apologize that I ran into this error. I had an earlier version of the cluster, but I upgraded it. So I upgraded it past to the point where this particular error showed up. And of course, I can't downgrade my cluster, and I didn't have time to install the new one. So I kind of showed you the piece parts running. Okay. But again, to summarize, it's an opinionated way of deploying operators for our shared services. We bring the operator in the cluster, and we also create CRs that cause the operand to be deployed. Those are opinionated in a configuration. And for parts of those operands that need to be exposed to adopters that want to interact with that operand, we create a CR about what should be bound to them. That actually then causes secrets and config maps to be copied over. And if these are updated over time, these copies are maintained, so that if they're injected into these requester pods and say certificates are rotated or say things like that occur, or these installed operands on the right-hand side are upgraded, then new artifacts will be copied back over to the, or refreshed artifacts will be copied over to the requester pods. That's how we keep in sync with our common services on the right-hand side and any cloud packs that want to use them. And some of our cloud packs are actually using ODLM to install their own services when they're within their own namespaces, just because it makes them easier for to say, here's the channels I want, here's the particular configurations I want, and codify them in kind of a config manner as opposed to inside of their own operator code to automatically cause those deployments to occur. So we do have some cloud packs that are doing this within a namespace, as I'm showing here, to install their own operands, and sometimes they're using them to actually copy and hide secrets with requester pods, just like is shown within this namespace. I kind of clicked here to make my mouse show up again, but this is a scenario I was just showing you. Are there any questions, or Chris, is there anything you wanted to add on top of that?
No, I'm good. I'm actually driving, so I can't do a whole lot of chatting. So.
Yeah, or pointing at the screen. I get it. All right. Any questions from anybody else participating? That's what I had in mind to show you. The details are out there in github.com/IBM/operand deployment lifecycle manager on what we did to make this work. We are using it, as I mentioned, to surface common services to our cloud packs, and our cloud pack deployers themselves are using it to automate their own deployments. It uses OLM in an opinionated way, and I don't know if there's any thought about OLM working this way in the future, but we're certainly open with collaborating with whoever wants to collaborate on this effort. All right, so I'll stop sharing. And I don't know if there are other things you wanted to discuss today, but that's what I was planning to show.
Yeah, no, Mike, that was a really great presentation. I definitely appreciate you taking the time to go over all of that with us. There's a lot of interesting things to think about there. I think Chris's point earlier about the way that OLM resolves or constraints on resolution for dependencies certainly seems to be very heavily related to some of the stuff that ODLM does. I'd like to start this thing on my own cluster and mess around with it, because I think there's probably some really interesting ideas in there that I think that the OLM developers could definitely learn about and from. So again, thanks a lot. That was really really good. Thank you.
So Kevin, if there's some help, I hope I can give you in playing around with this neural cluster and bootstrapping it like I showed you. Just reach out to me, either in Slack or email, and we can do that. Okay?
Yeah, that'd be great. Thank you.
All right. Thank you.
Okay, so there is not anything else on the agenda for today. Does anybody else have anything that they want to call out or talk about or anything like that?
Yeah, this is Chris. I'm not driving now, so I'm good. So last 2 weeks ago, we talked about procedures for how we want to participate and bring forth ideas and enhancement requests and things like that. And I think one of the to-dos, I think Nick Hale volunteered to do some collecting of a bunch of internal information and publishing in a Google Doc somewhere. I was wondering where that ended up.
Yeah, this is Nick. I have a set of internal documents that I brought forth to the team specifically on problems with dependency resolution and scoping, which I think was the breadth of the action item. I'm currently trying to figure out how I want to surface them to the working group. if I want to make like a shared drive somewhere that we can like start putting our sharing design docs and stuff in the future. Otherwise, I'm just going to share the doc with the Google group. Did we have any preference on that as a whole?
So personally, I think it seems reasonable for us to have a shared space just to put design documents that are more like living documents and things that wouldn't necessarily get committed to Git. Um, I think it's a good idea. Um, I don't know where to put that, but I just throwing my hand up saying that seems like the right thing to do.
Yeah. I'll take some time this afternoon. I apologize for the lateness of that, by the way. I'll take some time this afternoon and go look at the Cube different SIGs there and working groups and see how they have their drives arranged, and then I'll build out something and give the group access and drop those files in there. Sound good? Silence is golden. So I'll do that, and then I'll post a conversation in our working group sharing that. Thanks.
Thanks, Nick. Okay, anything else from anybody?
Another question I had was for, I think we talked about overriding the default channel on the index, the catalog index image. I had opened up an issue for that, an RFP for that. I was wondering if anybody had a chance to look at that. I feel like a broken record. I keep bringing it up every time. And then we talked about, at the same time, we talked about how we want to describe, how we want to work together on this. And we talked about using the Google group for some things, issues for other things, and actual enhancement request documents for other things. And so I threw something out there, but I think there was some, disagreement maybe on how we wanted to do that still. So I'm still a little confused of what we want to use Google groups for versus issues. Maybe Google groups more for announcements and side discussions, where issues are a little bit more formal discussion.
So yeah, I mean, I think for actual like in-depth technical discussions, I think what we've sort of recognized is email is hard to have that.
Yep.
So I want to say for this that continuing the conversation on the issue might be the right thing to do. At some point, when we have an idea of how we want to translate that into actionable design, I do still think that actually opening up a pull request with a design doc, whether that's a formal enhancement request or is just, we also have a section in our own repository in OLM for design proposals. So depending on where that design is in, like what state it's in, maybe that's the better place for it. But I do think that like the UI for GitHub to actually do like just have conversations about the pros and cons of a particular proposal is probably the best place to do it. I don't know what other folks feel about that. That being said, I think that the problem of how we have the conversation is still somewhat orthogonal from the problem of how do we go from concept to design proposal. And that I'm not as clear on exactly how we want to do it. So if people have thoughts about how that should work, I don't know what people think.
Well, I guess if I'm cool with whatever. If you want to use the design proposal and maybe do a PR, that can be nice too. Especially since you can overlay things a little bit easier. You don't have these super long threads of information in one Git issue, which could take forever people to read through sometimes. I guess could you respond to my thread in the Google group maybe with that, like where the design proposals would be versus the enhancement request?
Yes, I will take an action item to respond to that, and I will try to have a better answer about what we're going to do in the future, um, or at least have an idea of an option for how we want to do that. I don't
Yep.
know that I've thought about it as fully and as well as I should have. So I will come up with something and I will reply.
Awesome. So with respect to the specific feature of being able to set, basically having a new method on the index to be able to set a default channel, has any work been done on that yet?
So actually, this week I was having a conversation with a couple of developers. Um, I think that we're still in the process of scoping out what it would look like. But I think that the idea that we had, and maybe this is something that we should probably share out more formally once we have like better agreement on how we want to do it, is that the the specific function of like defining that one piece of metadata for a package in a catalog, uh, like if we just keep adding separate commands to OPM for every single one of those, it's going to be really hard to scale that up. And that probably what we want in reality is more of something like um, an abstraction around defining the graph as a set of metadata that you can like through a set of layers apply to an index, right? Like if there was a way to use OPM to pull some file down that just described the current state of the graph and the metadata around the packages, and that you could use that same JSON blob or YAML blob or whatever it is to modify that slightly and then pass that to the index, and then the index is updated with that change. That would be like more the way that you would be able to have a feature not just like that, but would solve a lot of the different metadata problems so that you could modify metadata outside the scope of pushing a bundle into the catalog. I think that's the thought. I don't know what folks think about that, but that seems like the direction we were thinking about.
No, that seems fair. Yeah, I guess if you guys could leak out some of the details of what you're doing, either in the issue. That's a problem with the issues because they kind of sit there and it seems like no one's even looking at them. So it's kind of hard to see what's actually going on unless we have these discussions and calls that kind of bring these things forward. Um, but I'm not sure if that's appropriate for the, just to say the issue, hey, we just talked about this today. Here's the proposal we're thinking of, that kind of thing. Just some communication that would be handy.
Yeah, I think that's reasonable. I'm also just thinking about like just in general the problem of as far as I know, the reason why none of this has been replied to or with any sort of formal proposal is because literally no one's written anything down. It's just word of mouth that I'm now regurgitating.
Yep.
And so if we had a way of, sorry.
I was just about to say one of those docs, I believe, that I was going to link was on this topic exactly.
Oh.
Yeah, index layers as channels. I think Evan wrote something up. That's more of like the design doc thoughts and ideas and comments in the Google Doc. It's pretty extensive, actually, now that I'm looking at it. So that's one of the things that we could probably link there, unless Evan has something else to say.
No, I was going to bring up that doc as well, although I would characterize it slightly more as like stream of consciousness than design. But I'm just curious how much of an issue this is right now. It seems to me like this is a pretty big gap in the tooling. And I'm wondering if there's a shorter term thing we should do just by adding the flag that Chris suggested as a quick fix for now while we work on the longer term solution, or maybe even something as simple as here's a one-liner that you can pass to the SQLite binary to edit the database and get it the way you want it.
Yeah, I'm actually okay if we manipulate the database directly as long as I am told the right way to do it for X version. Because we're going to have to use the database. We're going to be building our indexes similarly to how IIB does it. So IIB is the Red Hat certified operator builder thing. So we're going to be using OPM to manipulate the database registry, the registry database, and then we're going to be building the Docker images for that, because we have to do it that way to support multi-architecture catalog images, because OPM, of course, only supports one. And we're going to be using the Red Hat images because, of course, the upstream OPM doesn't have multi-architecture images there either. So anyway, so I think that would be okay because we have direct access to the database before we build these images. So that'd be an awesome short-term solution for me.
Yeah, I would lean towards adding a flag in OPM just so that whenever we do potentially migrate some of the backend side, you're not caught off guard by making direct access to a database that schema has changed or that format has changed or something like that.
No, I agree. Yep, we don't. Yep.
That said, I think this is the first I'm hearing about the multi-arch issue. I'm not aware of a reason that OPM won't work for that. You'll have to build each arch index separately, but then you can use Docker tooling to combine them into one manifest list.
Well, the problem is there's no base image that's being built upstream for anything other than AMD 64.
Right, that is true. Yeah, there are issues for that.
Yep, I know we opened one back in like March.
Right.
So,
yeah, I don't think we have a build environment that could build non-AMD 64 in upstream is part of the problem.
Yeah, that doesn't bother me because now that I know where the Red Hat built images are, I'm cool because we really want to use the Red Hat built ones anyway, so we can have a little more support, for the indexes as they're running in an OpenShift cluster. The issue we've got right now, of course, is the usual timing problem because the OPM registry that's built on 4.4 is the old, 0.5 vintage OPM in the registry where we need the 0.12.5. So that's in the 4.5 stream, of which is still in release candidate yet, at least for another week or so. I guess one of the questions is, are those images for the operator registry built in a way I can access them for the release candidates? They're not in the same spot as the GA versions in the OSE repos.
That is a good question. I do not know off the top of my head. I have to go look.
Okay, I was going to bring this up to some folks I have an interlock call on Monday, so I was going to bring up with those guys too. I'm actually on vacation today and tomorrow, so I'm not able to look right now, but I'm sure that they're somewhere because they're getting installed in release candidates. So
yeah, I just put a link in the chat, which I realize you might not have access to right now, but it's in Quay.io and it's the OpenShift org, but the repo is origin-operator-registry.
yeah,
so that's where that's where a lot of the pre-release stuff goes.
So
this is still just AMD 64.
I'm sorry, I was going to say, are they multi-arc in that registry?
That I do not know. I have to check.
Let's click on it and see if I can see. So then the only other hot button issue we have now is that that bug that Mike had displayed earlier, where the wrong default channel is being used. That's a major issue. So what? Do you know if that's going to make it into 4.5.0? And
that is already merged into 4.5.0. It's already in 4.5. And as you were talking, I looked and checked the status of the PR for 4.4. It's just waiting on our patch managers to pull it in.
So that would be like 4.4.11, presumably.
Yeah, presumably, yeah.
I think 4.4.11 closed last Friday, so it should be 4.4.12.
Bummer. Okay. So we have a set of poisoned Red Hat OpenShift releases we're going to have to steer customers away from for a while here. Okay.
Yeah, unfortunately, this is a regression introduced in another bug fix, so it did make it back to older versions of OpenShift.
And do you ever create hot fixes for, like, if a customer says, hey, we already migrated our cluster to 4.10, and now we're just completely in trouble, is there a way that they can request hot fixes for this one issue?
It is theoretically possible if they're working with like a support engineer that knows what they're doing. They can disable the CVO management of the operands and change the image to point to the new ZStream release image that has the fix. That will prevent updates for them. So they'll need, whenever they're ready to actually update to the version that actually has the fix, they'll need to undo that.
Right. So they'll stop them from getting any updates to anything because you've disabled the entire cluster version operator. Is that true?
It will stop them from getting updates to the cluster itself. It won't stop any OLM operator related updates.
No, right. The Cincinnati stuff, right?
Right.
Yeah. Okay. All right. Those are my hot buttons. Appreciate your thoughts on that.
Okay. Does anyone else have anything they'd like to bring up? All right. Well, if not, thanks everybody for the time. We can get done 9 minutes early. I know probably most people have a holiday tomorrow, so for those of you who do, enjoy the long weekend, and for everybody else, have a good one, and we'll see you all in 2 weeks.
Sounds good. See ya.
Thanks, guys.